Okay, good morning or afternoon rather. So this video is in particular for Bianca, but anybody else who may need help with how to do the conversions for your assignment. So first of all, you see here I'm in the Google Classroom screen. If you go to your classwork tab and go over to Chemistry e-learning, the assignment says week 1 Canvas e-learning. You click on that assignment, and if you watch the videos are actually listed as well. So let's see if I can show you that. Yeah. So these are the two videos where I explain how to do the conversions. This is the actual document that you need to open up to do the conversion. So I'll click on that now and open that up in a tab. So these are the actual conversions that you have to do. You do not have to do question 11, and you have to answer the questions for temperature, which go from 12 to 24. Again, if you watch the video, it will explain those. Now, so a lot of people are like, okay, I don't know how to do these conversions. First of all, you need to have the actual conversion chart in front of you at all times in order to do these problems, unless you've memorized them already, which if you have, that's great. If you haven't, if you go over here where it says temperature and pressure image, I actually made an image that has all the conversions there. So you see Kelvin is equal to C plus 273. And so you can rearrange that to get to Celsius. So that would be Kelvin minus 273 is equal to Celsius. And Fahrenheit is equal to 1.8 times C plus 32. Your pressure conversions are 1 atm is equal to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 101.3.25 kPa, and that's equal to 101,325 kPa. So I would suggest that you have this chart up in front of you as you're trying to work out the problems, okay? So here's an example. I'm going to go to the sheet and I'm going to open it up with Kami, because Kami, if you haven't tried to open up your assignments with Kami, I would highly suggest that you do that, because when you open it up with Kami, what happens is that you can actually annotate it and write on it directly on a PDF. And that's really going to be essential during this time when we're doing a lot of work from home. So what we're going to do is I'm going to go ahead and I'm actually going to go to question C. So if you watch the video, you know I did question A. So I'm going to do C right now. So just like all of your other dimensional analysis problems, I'm going to start by writing down my given and drawing the line. So right now I'm going to highlight the given. This is also a little Kami tutorial, huh? So I'm going to highlight the given here. As 0.75 atmospheres. So that's my given, and I have to go from atmospheres to kPa. Again, if you go back to your pressure conversion image, and I would again suggest having this open up in another, I would have that open up in another window if I were you, then you could go and look at that. So you can keep looking at it. Maxwell, can you give me a second? Give me 1 second, okay? So what you're going to do, let me pause for 1 second. Okay, so I'm back. Thank you for your patience. So the first thing I'm going to do is I'm going to write down my given, which is the 0.75 atmospheres, and draw my line. So I'll do that now, and I'm just going to do a text box. Again, there's a lot, let me put my computer down. There's a lot of different ways to do this, but we can do it by putting that text box. So let's see, I'm going to do text box. You can even do drawing and actually use your cursor to write. But we're going to just do a text box. And I'll make it, I think 12 is okay. So I'm going to make my text box, and I'm going to write 0.75 atmospheres. And then draw my line. Okay? Now, if you go back to the conversions, well, before we go back to the conversions, I'll make this a little bit bigger for you. I thought that 16 would be too big, but there we go. Now, what do we do next? What you're going to do is figure out what is the given and what's the unknown, just like we did those conversions in class. So since the given is atmospheres, then that means I have to put atmospheres at the bottom of my line, right? So I'm going to do that now. And since the unknown is kPa, I'm going to put kPa at the top of my line. Okay? Now, here's the problem. What are the conversions? You know, when we did moles, we said next to moles, put 1. Next to molar mass, put the molar mass. Next to grams, put the molar mass from the periodic table. Next to atoms, use Avogadro's number 6 times 10 to the 23rd. Same kind of concept here, except you are using these conversions. So we have 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 760 torr, and so on and so forth. So atmospheres is just simply 1. So when I go back to my chart, wherever I have the atmospheres, I will put a 1. And then I go back and I'm looking for kPa. Well, what is it for kPa? The number for kPa is 101.325. So that would go at the top of my line. So do that now. 101.325. Okay? So my conversion is now set up. What do I have to do? Well, we know the rules of doing dimensional analysis problems. We take our given, we multiply it times the number at the top, and we divide it by the number at the bottom. So let's do that now. If you need to pause this for a second to try on your own, that's fine. But I'm going to get my calculator. We're going to do 0.75 multiplied times 101.35. And then we're going to divide it by 1. So let's try that now. Okay, did you try it? So 0.75 times 101.325 gives me 75.99. Technically, we need 2 significant figures, but if you were to put 75.99, of course, I would not count off for that. But I am going to actually put it to the correct number of significant figures, which would be 75.99 would have to round to 2 significant figures. So this answer would be 76 kPa. Okay? And that's how you do your conversion problem. So again, you take whatever is given, you draw your horizontal line. You put the units of the given at the bottom, the units of the unknown at the top. Once you do that, you go over to your conversions chart and you figure out what number is in front. Remember, atmosphere is by itself because that is assumed to be 1. The number you go put in front of that is just 1. You plug in the numbers wherever they go, either the top or the bottom line. Then you take the given, multiply times the number at the top, and divide it by the number at the bottom. And you can keep it as is, or you can round it to the correct number of significant figures. And that is how, ladies and gentlemen, you do a pressure conversion problem. If you are having issues with the temperature conversion problems, just a check to see if you're paying attention. Do you have to do question 11? No, you don't. We'll work on those later on in the week. Or next week rather. So let's go on to question 12. I believe I did like the first 2. So let's go to question, this one. Let me highlight it. Because it's not like they're marked. It's just one whole problem. So I will, again, if you go over to your section, you can click on highlight. I can't even find highlight right now. Just know I'm doing this one, and I'm not sure why it won't let me highlight right now. See? Did that do it? No, it didn't. Hold on. Let me see where my highlight button is. This is what happens when you're trying to do something quickly. Mommy. Okay, so I can't find my highlight right now. but I just want to let you know that we're doing this problem where it's going degrees Celsius to 263 Kelvin. Hopefully you can see my cursor. All right, so I'm going to do it in a different color. I'll do it in blue, and that way you can see my math. So I got to change Kelvin to Celsius. Well, let's go back to those equations. Kelvin is equal to Celsius plus 273. So if I actually want to revert back and change it from Kelvin to Celsius, I got to take my Kelvin answer and subtract it from 273. So let's do that now. So I'm going to take the 263 Kelvin and I'm going to subtract it from 273. Well, let's back up. I'm going to actually write it out for you. K is equal to C plus 273. So that means that K minus 273 is equal to C. Just a simple rearrangement algebraic equation, right? So now what I'm going to do is go in and plug in my numbers. Okay, so K, which is 263, minus 273 is equal to my Celsius temperature, which gives me negative 10 is equal to C. Okay, so that's how you do the temperature problems. And hopefully you also understand how to do the pressure problems now. If you still need some help after this video, don't hesitate to message me if you need to. I will do my best to help you. Send me a message via Instagram, email, wherever you need to, and tell me which specific problem that you're doing. This would be super helpful. If you're working out a problem, like send me a message with a picture of exactly what you have already done to work it out, and then I can correct it and let you know if you're in the right track, if you need to back up a step. And I think that would be a lot more beneficial. Remember, next week we'll start some lectures for you guys. I'm not sure if I'll do it in Zoom or I'll do it via Instagram. I haven't decided yet, but that is for people who need some additional assistance outside of the videos that I'm recording from home. If you need more help, feel free to message me. Have a good morning.